Hello everyone, my name is Shami Bin Garden. Number matrix is CF220102. Today I'm going to present about beam staircase.
Hello, my name is Shani Bingalan. My matrix number is CF220102. Today I'd like to introduce you my structure. As you can see, this is my structure. And this is a type of engineering structure. And you can find on many buildings that have story level. The structure is called beam staircase and
In research, a simply supported beam on a staircase at the building Faculty of Civil and Built Environment at UTHM are chosen to be calculated, with actual size 4 meter length will be shown in the video submission as proof, and below is an actual photo taken for the structure of building at block M3. And this is the drawing and calculation that I have done. And you can see is first is idealization of structure and free body diagram and support reaction calculation. And here is the total of the calculation has done from on free body diagram. The answer is 49.04 kilonewton per meter, and for the support reaction is 24.33 kilonewton. And the next is for calculation of centroid. This is the drawing for centroid area. For the section 1, we have 3 parts here too, and exactly is for area, x, y, ax, and ay. And the total for area is 0.96, and for ax is 1.272, and ay is 0.126. Therefore, here is the formula that we have is 1.33 meter for x, and y is 0.13 meter. And the next is for the calculation of moment of inertia. This is the section that we have done. We concluded this for the answer for x-axis is 0.092 meter for, and for y-axis is 1 to 0.852 meter for. In the last one is for the conclusion. We conclude that the staircase at the building Faculty of Civil and Built Environment at UTHM with assuming the uniform distributed load UDL is 500 kilonewton per meter, with the length distance is 4 meter, and the type of reaction is identified as fixed and support. Henceforth, the centroid of the structure is identified with x-axis equal 1.33 meter and y-axis equal to 0.13 meter. Meanwhile, for the second moment inertia, the stress in the slab for the structure has been determined with the IIX stresses equal to 0.092 meter for and IYY equal to 12.852 meter for. With the data collected through calculation, the beam staircase is secure to step up and to go down for all people at UTHM. And that is all. Thank you.
Hi, Assalamualaikum. My name is Nuzul Syatikin Betulinail. My matric number is AF220042. Today, I would like to introduce you my structure. As you can see, my structure is roof, which is one of civil engineering structure. Roofs cover the top of a building, serving to protect against rain, snow, sunlight, wind, and extreme of temperature. Roofs have been constructed in a wide variety of form: flats, pitch, vault, dome, or in combination as detected by technical, economic, or aesthetic consideration. In this research, a roof at a building in front of College Kediamatan Dr. Ismail, which is Wakaf Tun Dr. Ismail, is chosen to be calculated. This is a free body diagram and a calculation of support reaction. The magnitude of this structure is 300 Newton, mass of load is 30 kilonewton per meter, and the length of roof is 10 meter. This is the center of the roof structure. For the x-axis is equal to 8.337, and for the y-axis is equal to 4. Lastly, the moment of inertia for the x-axis is 277.8 meter to the power of 4, and for the y-axis are equal to 144.485 meter to the power of 4. In conclusion, the roof structure at a building in front of College Kediaman Dr. Ismail, which is Wakafton Dr. Ismail, has a total mass load of 30 kN per meter with a long distance of 10 meter, and the type of support is identified as fixed end support. Therefore, the center of the structure identified with the x-axis is equal to 8.337 meter and the y-axis is 4 meter. The moment of inertia of this structure has been determined with Ix stress equal to 277.4 meter and Iyy equal to 144.485 meter.
Hi, Assalamualaikum. My name is Muhammad Aman Kim Mazuni. My meter number is CF220025. Today, I would like to introduce you my structure. As you can see, this is my structure, Perwira Bridge. The length is around 6 meter, and I use pin support for berth, for berth support. The introduction is a bridge is a structure which is built over some physical obstacle such as a body of water, valley, a road, and its purpose to provide crossing over that obstacle. It is built to be strong enough to safely support its own weight as well as the weight of anything that should pass over it. Okay, this is the picture for bridge at Perwira, and this is for free body diagram. And the estimation of load is the mass of that load is 8,000 kg and the weight is 78.48, and the W is 78.48 divided by 6, and it equal to 13.08 kN per meter, and the total loading on beam is 13.08 times 6 equal to 78.48. For separation is I got 39.24, and for the center of the area is it has a 4 section. Okay, the total area is 10, and for the total AX is 20, and the total AY is 5.5. And for X, the formula is AX, total AX divided by total area, and I got a 2. For Y, is total AY divided by total area, and I got 0.55. For moment of inertia, x-axis, for the IX, for IXS I got 2.82, and for y-axis or IYY I got 33.34. So the conclusion is we can conclude that the structure, which is short span bridge at residential college, the application for thermodynamics is quite important for daily life. And from the conclusion, we can consider this structure is strong and stable. Lastly, the separation, central, and moment of inertia that have been calculated, and the value for all of it are very logical and accurate and reasonable. Thank you.
Assalamualaikum. Hello and hi everyone. My name is Muhammad Zakaria bin Supian, holding matrix number AF220014. Today I will introduce to you about a structure that has been built near the UTHM area. As you can see at the back, it is a type of civil engineering structure that you can found in a certain area, mostly in the residence area. This structure is called a water tower. This water tower is a tall structure that store pressure potable water system. The water tower typically store drinkable water that can be used by the local people or the community. Uh, the water tower are built on high ground to provide enough pressure to force water into a public water supply. Actually providing all customer in the area. The tank of the water tower is large and it can contain about 1 million gallons or more of water. The majority of the water tower are designed to hold up to 1 day's worth of water for the community they serve. Steel and concrete are two common building materials of water tower. As you can see, uh, at the bottom of this construction is a pillar that are made of brick and concrete, and it used to support the water storage tank. And at the top, we can see the location of water tank, which could be made of plastic or stainless steel. This structure was constructed in a highly populated area to ease the storage of clean water, which will be channeled to the local people. Uh, that's all for me. Thank you.
Hello, Assalamualaikum. My name is Zaid Azmi bin Zaidi Anwar. My matrix number is CF220138. So for the introduction, columns serve as a structural component that transmits loads from a structure slab. So the column that I choose is at building E15 UTHM um, uh, with, with actual size 200-meter height and 10 kilonewton load. Okay, so this is the actual structure that I choose for the column. The location is at E15 UTHM. Okay, so this is my free body diagram. So the height of the column is 200 meter and the length is 10 meter. For the force is 100 kilonewton and the load is 10 kilonewton. Okay, so for the moment of my structure is 50 kilonewton. Okay, so this is my calculation for the center of the area. So for the X is 37.63 meter and for Y is 36 meter. So this is my calculation for Y axis.